Hello everyone, I want us to solve this linear programming problem using graphical method, and in our last video I've given you the procedure or the steps that we usually use when it comes to solving linear programming problems using graphical methods. So make sure you watch our previous video so that you can have a clear understanding of what we are going to be doing in this video. So we are asked to solve the following linear programming problem using graphical method, and this is the objective function, which is we maximize z, which is equals to 300x1 plus 250x2, subject to these are the constraints. The first constraint says 2x1 plus x2 is less than or equal to 40. Then the second constraint, x1 plus 3x2 is less than or equal to 45. The third constraint is x1, which is less than or equal to 12. So x1 and x2, which is greater than or equal to 0, it means that both x1 and x2, they must give you positive values, i.e. or meaning that x1 and x2, they must give you at least 0, meaning they can be 0 or more than 0. They can be 5, 7, 9 all the way, but they must not be less than 0. So what you need to do for us to be able to solve this linear programming problem using graphical method, because we have been given the constraint functions. So this is the first one, the second one, and this is the third one. So what you need to do, because I remember in the previous video I told you that for us to be able to solve the linear programming problem using graphical method, we usually graph each constraint function. So this is our first constraint, this is our second constraint, and this is our third constraint. So what we need to do, we need to plot all these constraint functions on a Cartesian plane. So let us start with the first constraint. The first constraint, and we have been given the first constraint as 2x1 plus x2 is less than or equal to 40. So what you need to do, you need to change this inequality to equality. So what do I mean? So you take 2x1, you add x2, then you equate to 40. Now you need to come up with a table of values that will enable you to get the points that you are going now to plot on the Cartesian plane, so that you can be able to obtain the curve for this particular constraint. So in this case, assume so this is the table that I'm talking about. So assume this is x1 and this is x2. So because we need 2 points to plot on the Cartesian plane, so what you need to do, we are going to find the values of x1, and then from there we find the points on x2, so that you can be able to plot them on the Cartesian plane. So in this case, we can say these when x1 is equals to 0, what is the value of x2? What is the value of x2? So in this case, because this is the constant function, which says 2x1 plus x2 is equals to 40. Now, because we have said that when x1 is equals to 0, now we are now finding the value of x2. So we replace x1 with a 0. So this is 2 in bracket 0 plus x2 is equals to 40. So this one is x2, because 2 times 0 it will give you 0. So x2 is equals to 40. Higher. So here, when x1 is 0, x2 is 40. Now, let us assume when x2 is equals to 0, what will be, or what is the value of x1? x1, what is the value of x1? So assume x2 is equals to 0. Now, we are looking for the value of x1. So in this case, because it's our constant function, which is 2x1 plus x2 is equals to 40, we are going to replace x2 with a 0. So this is 2x1 plus 0 equals 40. So 2x1 is equals to 40. So meaning x1 equals 40, you divide by 2. Divide by 2 here. So you get as x1 as 20. So write 20 here. Now what you need to do on our graph here, when x1 is equals to 0, x2 is equals to 40. So I have a graph here, and on this horizontal axis it stands for x1, but on this vertical axis it stands for x2. So I've said when x1 is equals to 0, our x2 is equals to 40. So meaning if x1 is equals to 0, x2 is equals to 40. So this is the point. Now the second step says when x1 is equals to 20, x2 is equals to 0. So when x1 is equals to 20, our x2 is equals to 0. So meaning it is this particular point. So what you need to do, we need to join these points, or these 2 points. So this curve is a curve that is obtained by this constraint number 1, which is 2x1 plus x2 is equals to is less than or equal to 40. So we need to label this curve, which is 2x1 plus x2 less than or equal to 40. Now because our constant says 2x1 plus x2 is less than or equal to 40, meaning any other point that is above this particular curve, it is the unwanted region. So what you need to do, we need to shade this region. This is the unwanted region. That is the unwanted region. Let us now go to constraint number 2. Our second constraint, we have been given our second constraint as x1 plus 3x2 is less than or equal to 45. So what you need to do, I told you, you need to change the inequality to equality. So this x1 plus 3x2 is equals to 45. Now we come up with a table of values. So this is x1, this is x2. So when x1 is equals to 0, when x1 is equals to 0, so what is going to be the value of x2? So in this case, we have x1 plus 3x2 is equals to 45. We replace x1 with 0. So is 0 plus 3x2 is equals to 45. So 3x2, no, sorry, x2, yeah, 3x2 is equals to 45. We divide by 3, we divide by 3. So x2 is equals to 15. So when x1 is 0, x2 is 15. Now we do the vice versa. So when x2 is equals to 0, what is going to be the value for x1? So in this case, when x2 equals 0, what is going to be the value for x1? That is the question that we need to ask ourselves. So in this case, because we have the constant function, which is x1 plus 3x2 is equals to 45, we replace x2 with 0. So x1 plus 3 in bracket 0 is equals to 45. So this x1 is equals to 45. So you write here 45. Now we go to our graph. We go to our graph. And our graph can be able to see that when x1 is equals to 0, x2 is equals to 15. So x1, it is this horizontal axis. When x1 is equals to 0, x2 is equals to 15. So this is 0. 15, it is somewhere here. This is 11, 12, 13, 14. This is 15. So when x1 is equals to 0, x2 equals 15. This is the point. And then when x1 equals 45, x2 is equals to 0. When x1, this is x1, when x1 is equals to 45, x2 is equals to 0. So meaning this is the other point. Now we join the 2 points. We join the 2 points. We join the 2 points. And this is the curve for the second constraint. And the second constraint is x1 plus 3x2 less than or equal to 45. So these are x1 plus 3x2 is less than or equal to 45. And because it is less than or equal to, so meaning any other point that is above this curve, it is supposed to be the unwanted region in this particular case. So this one is going to be an unwanted region. Let us now proceed with our question. In our question, we have been given 3 constraints. We have been given 3 constraints. The first one, so in our question, we have been given 3 constraints. The first one we have been able to plot, the second one, and then we have the third one, which is x1 is less than or equal to 12. So x1 is less than or equal to 12. So we change the inequality to equality. So x1 is equals to 12. So we go to our graph. I told you on the horizontal axis, it stands for x1. So where x1 equals to 12 is where you are going to draw our curve. So this is 10, 11, 12. So meaning the line which is x1 this x is equals to 12. So because our constant says that x is equals to less than or equal to 12, any other point that is beyond 12, it is going to be unwanted region. So using the steps that I gave you on linear programming, I told you after you have been able to shade the relevant zone, that is the unwanted region, now you use the inspection to settle on the best point, that is the optimal point. You take the corner rules. So, the corner points. So what you need to do, this is going to be our point A. Then the next corner is going to be this one. This is going to be point B. Then where these 2 points are intersecting, this is going to be our point C. And this one is going to be our point D. So here we have 4 points. We have point A, point B, point C, and point D. Now, we need now to pick the coordinates of the corner points and substitute them to the objective function. So, the coordinates for point A are 0, 0. The coordinates for point B, which is this one, are 12, 0. The coordinates for point C, here we have 12, and this point is 11. So this is 12, 11. And the coordinates for point D are 0, and this is 15. 0 and 15. Now, what we need to do so that we can be able now to find the maximum, what you need to do, we write maximize the objective function, which is z equals 300 x1 plus 250 x2. Then let us write z at point A, z at point B, z and this point D. So the coordinates of A are 0, 0. The coordinates of A are 0, 0. The coordinates for point B are 12, 0. The coordinates for point C are 12, 11. And the coordinates for point D are 0, 15. Now, what you need to do, we take the objective function, we replace these x values with the coordinates. So in this case, this one is going to be 300 x1. This one is x1, this is x2. So this is 0. You add 250, then you get 0. So this one is going to give you 0. Let us go to the second one. The second one, this is 300 in bracket 12 plus 250 in bracket 0. This one is supposed to give you 3600. The other pointer, we have 300 in bracket 12 plus 250 in bracket 11, supposed to give you 6350. The last one, we have 300 in bracket 0 plus 250 in bracket 15. So it's supposed to give you 3750. So the points that are giving us the maximum value is this one, 6350. So we can say these you pick the highest, pick the highest value. In this case, the highest value is 6350. So the z value is maximum for the corner pointer, for the corner point C, which is this one, 12, 11, whereby x1 is equal to 12, x2 is equal to 11. So z or z optimum, it will be 12, 11. So that's how you solve a linear programming problem using graphical method. So in case of any question, drop it at the comment section. Thank you so much for your time.